So apart from circles for polar curves, there's a number of graphs that can be a result based on different trig functions and combinations. So the first one is going to be a rose curve, which looks somewhat like a flower. So it's generally in the form r of theta equals plus or minus a sine n of theta, or the same thing for cosine. And the first step that we need to do in order to graph our curve is to find the number of petals we have. So this will be done by looking at the n value, which is inside of the trig function. So if the n number is odd, then the number of petals is going to be just n petals. But if it's even, we're going to double it. So there's going to be 2n petals. The second step is finding the length of the petal, which is just going to be our a value, whether it's positive or negative. And next, third one is the spacing of the petals. And that is just going to be using the simple formula 2 pi over the total number of petals. So the first, let's do an example. So let's say we want to graph the function r equals negative 4 cosine 4 theta. So first step is finding the number of petals. And we'll look at our n number inside, which is 4, which is an even number, so we're going to double it. Meaning the number of petals we have is 8. Second step is going to be the length of the petals, which is just going to be our a value, just here, it's going to be 4. Third, we want to find the spacing. The spacing is going to be 2 pi over the number of petals, which is 8, which simplifies to pi over 4. And finally, we want to do our reference petal. And in order to find the reference petal, what we do is for cosine, if the function is cosine, we set the inside, which is 4 theta or n theta, equal to 0, because 0 is when cosine is at a maximum. And similarly, if the function is sine, we'll set n theta to pi over 2, because pi over 2 is when sine reaches a max, which are both 1. So in this example, we have a cosine. So for our reference petal, we're going to set n theta for theta equal to 0 and solve for theta, which we're just going to get 0. So that means our first petal is going to be at an angle of 0 radians, and we're going to keep going with a spacing of pi over 4. So let's start on this graph here. We'll start at the origin, and we're going to go 0 radians, which is just going to be on the x-axis. It's going to be 4 units long, because that's based off the a value, which is 4 in this case. So this here is going to be our reference petal. Now we want to do the same thing, but we want to space it out by pi over 4 radians. So pi over 4 is here on this line. So we're going to do the exact same thing, again maintaining a length of 4. And we're going to do that again. We're going to space it out again by pi over 4. So now we've reached pi over 2 radians. And we'll make a petal like that and just keep going, spacing out by pi over 4 every time. So on our last pedal, we should see that our number of petals should match up with what we calculated earlier. 6, 7, and 8 is what we calculated. So here's how we do a rose curve graph for -4 cosine 4 theta. So the next graph that we need to know is a cardioid, which is kind of like a heart. So a cardioid is when you have your function as a form of a plus or minus b cosine theta, or it could be sine as well. And here is when a cardioid is going to be when a and b are the same. And again, it creates a heart-like shape. So let's say we want to find just a general curve. We'll take this one for example. So since it's a cosine graph, it's going to be pointing in a direction either left or right because cosine is the x-axis. So for example, let's take 2 plus 2 cosine theta, another function that we want to graph. So 2 and 2 are the same, so this is going to be a cardioid, and it's a cosine again, so it's going to be pointing left and right. So we all know that a heart shape looks somewhat like this, and the way that we figure out the lengths of different components of it, so this dotted line from this edge to the middle is going to be our A value, and same thing on this side. However, from this tip of the center to the bottom tip, that is A plus B. So in this example, we're going to have our center per se at a length of A plus B, which is 4, and we're going to have our two tips at a length of A, which is just 2. So now we can go and graph this. Now we know that, again, it's cosine, so it's going to be pointing to the right because it's a positive case in this instance because A is 2. So that means that this tip is going to be facing to the right. So we'll start at the origin again for our two tips of A length, and we know that that's 2. So we'll just extend them out like this in either direction. And then we know that this center to the edge of our heart shape is going to be A plus B, or 4. So this is going to be the ending point. So we'll just connect the two like this, and we've completed our cardioid curve. The next one is called an inner loop limicin. So this is the same form as a cardioid, except the A and B values are going to be different. So an inner loop limicin is where the absolute value of A over B is less than 1, which basically just means that A is less than B. This creates a similar cardioid shape, but there's going to be an inner loop. So let's take the example of r equals 2 plus 3 cosine theta. So we'll get our graph here again. And we know that 2 is less than 3, so it's going to be an inner loop limit. So what an inner loop looks like is it's again a heart, but when we get to the center, there's going to be a loop out like that. And the value calculations are somewhat similar. So again, one tip will be the value of A, which in this case is 2, and the length from this edge to the bottom tip of the heart is going to be again A plus B. And now for the inner loop, the distance between the edge of the heart and the bottom of the loop is going to be B minus A. So we know our measurements for the tips are 2, then the center edge length will be A plus B, or 5, and the inner loop is going to be 3 minus 2, which is 1. And again, this is a cosine function, so the tip is going to be pointing out to the right because the B value is positive. So we'll start at the origin again, making our same tips of 2 length, and now we'll have a loop inside of length 1. So we'll have it just go like that. And then again, center length here is going to be 5. So we'll just connect it to 5 on the x-axis. And here is our finished graph. The last one that we need to know is just a limicin, not an inner loop one. And this is the same form as the other two. However, this time it's going to be when A is greater than B. So an inner loop is when B is greater than A, and a non-inner loop is where A is greater than B. So this creates somewhat of a heart shape, but it's can be referred to maybe as an apple or a flat tire, which looks somewhat like this. So we'll have an example. Let's say we want to do r equals 4 minus 2 cosine theta. So our A value is greater than our B value. And our measurements are going to be kind of the same as before. So we have, imagine this to be the center. So each tip again is going to be our A value. And here, from the end of our edges, which is here, this distance is going to be, again, A plus B. So let's graph this. It's going to be cosine, so it's pointing out. But this time, since our B value is negative, it's going to be pointing to the left. So we'll start at the origin again and make our 2 tips of A length, which is going to be 4. And we'll make sure that they extend outwards, meaning this length of a length of B. So it'll be 4 tall and extend out 2. And we'll repeat that on the other side like this. And then again, we want a center length, which is A plus B, which is going to be 6, and we'll just connect the 2 out like that. So here's our final graph of 4 minus 2 cosine theta.